What if you could expose a simple calculation to your AI assistant with just 3 lines of clean, type-safe Python? You'll see how to create a basic, FastMCP tool that performs integer addition, complete with automatic parameter validation and schema generation. The pattern demonstrates the absolute minimum needed to make a Python function callable by AI models through the MCP protocol. At MCP tool, def calculate sum A, int B, int. Calculate sum with return annotation. Return a plus B hash returns 8. This demonstrates the AI tool integration pattern, where Python functions become callable endpoints for language models. The decorator-based approach transforms ordinary functions into structured tools with automatic schema generation, validation, and type safety. What makes this distinctive is how it bridges the gap between human-readable code and machine-consumable interfaces without requiring manual API definitions. The pattern works by leveraging Python's type system and decorator metadata to create self-describing tools. Type annotations define the input-output contracts, while the decorator handles registration, schema generation, and protocol compliance. This separation of concerns means your implementation stays clean, focused purely on business logic, while the framework manages all the RPC infrastructure, including parameter validation, error handling, and transport serialization. This approach solves the problem of safely exposing backend capabilities to AI systems. It eliminates the need for custom API layers, manual documentation, or ad hoc validation code. The pattern shines in scenarios where you need to dynamically extend an LLM's capabilities with private data or proprietary logic, while maintaining strict type safety and runtime validation. The trade-off is some initial decorator overhead, but it pays dividends in maintainability and reliability compared to manual API development. Let's break it down line by line. At MCP tool, def calculate sum A, int B, int. Calculate sum with return annotation. The @MCP tool decorator marks this function as AI-callable through FastMCP. Type hints and docstring automatically generate the tool schema, enforcing input validation and API documentation in one. This is the standard pattern for exposing Python functions to AI models. Type safety and self-documentation become first-class features. Return a plus B hash returns 8. This implements the actual computation, returning the sum of inputs, A and B. The comment indicates the expected result for the specific inputs defined elsewhere in the test context, serving as an inline assertion. This pattern keeps test expectations visible alongside the implementation. FastMCP tool schema generation. The @MCP tool decorator automatically creates JSON schemas from Python type hints, wrapping primitive returns in a result key for structured output. Returning raw primitives without proper type hints breaks schema validation and client expectations. This pattern bridges Python's dynamic nature with AI's need for predictable typed interfaces.
The schema that describes everything must itself remain invisible.